much the heights vary. So what is probability? So probability is like something happened. It shows how a fraction, decimal, or ratio values range from 0 to 1. So 0 is impossible. It is not happen. And 1 is certain. It is definitely happen. So probability formula. So P, or the event, equals number of favorable outcome divided by total number of possible outcomes. So example of that is, imagine that you're flipping a coin. So there are two possible outcomes, head or tail. So the probability of getting head is 1, favor or the favorable outcome, over or divided by 2, or the total outcome, equals 1/2 or 0.5. So you can answer this question. What is the probability of rolling 4 on a standard 6-sided die? A, 1/6, B, 1/2, C, 1/3, D, 2/3. So here is an example to make it more understandable. The outcome result is a one result. The event there is one or more outcomes. So experimental probability is based on actually happens when you do something. So the formula for this is P, or the event, equals number of times event occur divided by total number of trials. So example of this, a coin is tossed 20 times. Heads appear 12 times. So P, or the heads, is equal to 12 over 20. So experimental probability depends on result, not theory. So let's say, for example, if you roll a die 30 times and the number 5 comes up 7 times, experimental probability of rolling a 5 is 7/3. Okay, now we will explore to the dependent event. So a dependent event is one event does not change the outcome of another event. So example of this is tossing a coin or rolling a die and two separate coin tosses. We will explore to the independent events. An independent event is one event does not change the outcome of another event. So example is tossing a coin and rolling a die. So dependent events is one event affects the outcome of another event. So example of this is drawing cards from deck without putting them back, and also picking marbles from a bag without putting them back. Here's an example. Flipping a coin twice is independent. First flip does not change the chance of getting heads or tails on the second flip. But if you draw a card from a deck and don't put it back, the chances of drawing a specific card next time change because there is one last card in the deck. You can answer this question. Which of the following is an example of dependent events? A, rolling a die twice. B, flipping a coin and spinning a spinner. C, picking a name out of a hat and then picking another name without putting the first one back. D, choosing a number between 1 and 10, then choosing another number between 1 and 10. Now, we'll move on to the compound event. It's an event with 2 or more compounds. So example, rolling a number greater than 4 on a die. So 5 or 6. Addition rule of probability. So this is used from finding the probability that either event A or event B happens. So P, event A or B. So example, a die is rolled. So what is the probability of getting A1 or A6? So it's P is equal to 2 over 6. Here is an example. If you want to know the probability of drawing a red card or a face card from a deck, that's a compound event. You'd use the addition rule to figure out the probability. So you can answer this question. What is the probability of ruling an even number or a 5 on a 6-sided die? A, 1/6, B, 1/2, C, 1/2, D, 5/6. Now we'll move on to the multiplication rule of probability. So use when finding the probability that both events occur. So P is the A and B. So example of this is the tossing a coin and rolling a die. So what is the probability of getting heads and A4? So P is equal to 1/2 times 1/6 is equal to 1/12. If you want to find the probability of drawing ace from deck of cards and then flipping heads on a coin, you'd use the multiplication rule. So you can answer this question. What is the probability of rolling a 3 on a die and flipping tails on a coin? A, 1/2, B, 1/6, C, 1/12, D, 1/3. Now we will move on to solving word problem. So general steps of this is, first one, you read the problem carefully. Next one, you identify what information is given. Third is figure out what the problem is asking you to find. Then next one is you choose the right math idea, or it could be mean, median, or the probability. And then the last one is solve the problem and explain your answer. So example of this is the word problem. John has 10 apples and Mary has 5. How many apples do they have together? So you have to read, understand the question given. So John has 10, Mary has 5. Ask total number of apples. Concept, it is addition. Then the solve is 10 plus 5 is equal to 15. Then they have the 15 apples together. So application, the average score of a class. So average means the mean. So mean is equal to sum of scores over number of students. So used to describe overall class performance. Typical score. Here is an example. Class have scored. So you just going to add it all and then divide it with 5 and equal to 80. So the average score is 80. The next one is probability of selecting students or objects. Basic probability formula. So the P or the event is what we have gathered earlier. Favorable outcomes over total outcomes. So example is a class has 20 students, 5 are left-handed. So P selecting a left-handed student equal 520. So the probability is 1/4. So you can answer this question. What is the probability of a randomly selecting girls from a class of 30 students, or there are 12 girls? So A, 12/30, B, 18/30, C, 30/12, D, 1/30. Now, the interpretation of survey results. So, survey is a way of collecting information from group of people. So, data may be shown using tables, bar graph, and pictograph. So, let's say, for example, is a survey shows a favorite fruit of the student. Like the mango, frequency is 10, banana, frequency is 6, apple, the frequency is 4. Now, we will move on to what is technology integration? So it's using digital tools to make teaching and learning better. So technology should help you understand, not just replace thinking. So why use technology in statistics? So technology help you organize data easily, create correct graphs, see patterns and trends, and make fewer calculation mistakes, and also understand data better. So let's say for an example is, instead of just drawing a bar by hand, you can use computer program to create a perfect graph quickly and easily. This help you focus on understanding the graph shows. So you can answer this question. Which of the following is not a reason to use technology in statistics? To organize data efficiently, to replace critical thinking, to reduce computation errors, or to visualize patterns and trends? Now, the common digital tools used in elementary in statistics spreadsheet software. So it's the Microsoft Excel and Google Sheets. So these are used for entering data, making tables, and creating graphs, and also basic analysis. So for an example is, you can use Excel to enter a list of test score, create a table showing the scores, and then make a bar graph to visualize the data. You can answer this question. Which of the following is an example of spreadsheet software? Microsoft Word, Google Sheet, Microsoft Excel, or Adobe Photoshop? Now, the data entry using digital tools. So data entry is entering data into rows and columns. Each value is replaced in a cell. So example, student quiz scores, or survey result, or attendance record. So another example of that is, you can enter a list of students' name in one column and their corresponding test scores in the next column in a spreadsheet. So you can answer this question. In a spreadsheet, where is each individual piece of data placed? A, row, B, column, C, cell, D, table. Now we will move on to the organizing data digitally. So digital tools help in creating frequency tables showing how often each values appear, and sorting data ascending or descending order. So grouping similar values also. Example is, you can use a spreadsheet to sort a list of students' test scores from highest to lowest, to create a table showing how many students scored in each grade from A, B, C, and etc. Now, creating bar graphs using digital tools. So bar graphs used to compare categories, right? So, example, for favorite fruits, number of students per section, and survey results. So digital tools automatically scales access correctly and label bars clearly. So example is, you can create a bar graph to show the number of students who like each type of sport: basketball, soccer, and etc. The height of each bar represents the number of students who like that sport. Now, creating line graphs using digital tools. So line graph is used to change over time. So daily, example, daily attendance, weekly quiz, monthly temperature. So example is, you can use line graph to show how temperature change each day, every or over a week. This line goes up when the temperature increases and down when it decreases. Now, proper labeling of the digital graphs. Every graph must include title, x-axis label, and y-axis label, and appropriate scale. So example is, if you're making a graph of student test scores over time, the title might be the student test score, and the x-axis label might be date, and the y-axis label might be the score. The scale should be appropriate for the range of scores. Now, analyzing data using basic software features. So basic features include the sorting values, identifying highest and lowest values, viewing patterns and trends, and comparing categories visually. Example is you can use spreadsheet to sort a list of student test scores from highest and to lowest. Easily see the highest and lowest scores and create a graph to compare the scores of different class. Now, the interpreting data generated graph. So students can identify the most frequent category, compare the data sets, and observe increase or decreases, and also make simple conclusions. So let's say, for example, looking at a bar of favorite colors, you can easily see which color is the most popular. Looking at the line of temperature over time, you can see when the temperature increase or decrease. So you can answer this question. What is something you can do when interpreting a graph? A, change the data. B, identify the most frequent category. C, create the graph. D, delete the graph. Now let's review all the things that we learned today. So it covers the probability, descriptive statistic, which is the mean, digital tools for data analysis, and problem-solving step. Key ideas is the probability is a theoretical versus experimental formulas for basic and combined probabilities. While statistic calculate the mean, the data interprets the table, the bar graphs, and the line graphs. And the tools use spreadsheets to data enter, organization, graphs, and label graphs properly. Problem solving, it follows step. Read, identify, choose concept, and then. So the most common questions or concepts that might come up in the exams are data interpretation, probability calculations, problem solving, and technology integration, which is the spreadsheet. To further know this kind of concepts is the resources that you can do is websites like the Khan Academy, the Hat Quick, and practice problem online and statistic textbooks. Thank you for watching. Practice this concept, ask question, and good luck. Bye-bye.